Hello, this is just a quick video explaining some key object-oriented programming concepts, just so you can get a greater understanding of what's being covered in class. So I've created here a few classes which I'm going to work with. So I've got my main, which is going to house all of my code for executing. So this is going to be my executable class. And here are my object classes, which just represent some data. So I've got a house, I've got a room, a window, and a door. So the first thing we're going to need is our main method, which is our gateway to our program. And every main method is the exact same. So it's public static void main string args, and then open up a pair of curly brackets. Once we have this, we can execute our program. And we can do this by hitting the little play button or by using our run window up here. So our program does nothing. But we've got here some classes, and you'll find that these classes are all empty, but we can still create instances of them. So I can type house equals new house, and because they're in the same package, we don't need to import anything. And that needs some curly brackets, of course. So what the Java compiler here is doing is it's creating something called a constructor behind the scenes, which is a special type of method which initializes variables. So if I go to my house and I create a constructor, which is what this looks like, and if you look up in the top right, I have a chart showing what buttons I'm pressing, so Alt and Insert to generate. And you don't need to create an empty constructor because it's done for you by the compiler. Now, what we're going to do is we're going to create multiple classes here, and we're going to put them all together. So there are several key concepts for object-oriented programming, and they are inheritance, encapsulation, abstraction, polymorphism. So what we're going to aim to do is we're going to create a house using these constituent parts. So the first thing we're going to do is we're going to list out what properties of our house they're going to be. So we could have an address, we could have an owner, we could have inhabitants, and for that we could have an array maybe. And then we get to polymorphism, which is the process of making objects from other objects. So we could have our windows, or sorry, no, that would be window, an array of windows, an array of doors, what doors there are, and what rooms there are. So now we've got a whole bunch of fields. These special variables are called fields because they're specific to an instance of a class. And it's describing a house, but it's describing any possible house. It's not describing any one house. And in order to create any one house, for example, my house, we would need to give these objects values, a process called initialization. So in order to do that, we need to create a new constructor. So again, in order to do that, we press Alt Insert, press Enter for constructor, Control A to select everything, and then Enter. And this will generate a constructor. But what this does is it basically creates a method which has a whole bunch of parameters. It's not a method because it has no return type. And then it lets this equal to this. And of course we use the this keyword. And what this refers to is this variable here. So we're giving this variable a value, which is this. And I know my constant use of this can be confusing. So now that we've got our constructor, we can actually create a house using these particular parameters. So now you'll see that there's an error here because there's no longer an empty constructor. So we actually have to give it some values. So we can do, let's actually just open this to the side so we can have a look at it. So our first one is address. So we could have main street. Our owner can be me. Our inhabitants is going to be an array, so you can have a new string and then pass in a literal. Now I'm going to go into the next line so you can see it. So we could have Ken and Jennifer, for example. Then we need to give it windows. So right now we're not going to actually give the windows any values. We're just going to create 2 empty arrays. And then we need to do the same for door and rooms. So new door and new rooms. Oh, that should be capital R and no S. All right, so that got rid of all of the errors. So what is this doing? Well, it is creating an instance of a house with these particular variables. But if I create another house, and I'll copy and paste it, and I change something to be like 123 Street, these are no longer the same house. They're not equal. They're 2 different instances of house. And this is why we have objects, because our class sets out the properties of an object, but then we can have instances of the object which represent those in different ways. So now that we've got our house, we can actually give it some more detail. So right now, window, door, and room don't tell us anything about the house. But we can go into these objects and we can create more information. So for our windows, we could have a array of ints, which is dimensions, so how big are the windows. We could have a boolean, which is double glazed, etc., etc. And again, we can create a constructor for that. And we can do the same for door. We could have dimensions again. And we could have our material type. So we could do material type. For this example, I'm going to use a string, but normally for something like material type, you'd use something called an enum. And again, we can create a constructor. And then for room, we could have, I don't know, just a list of objects which are in the room. Why we use a list? Well, you can take things in and out of a room. So we don't want it to be fixed like an array. And we could put that as contents. And again, create a constructor. So now we've actually given this one house object quite a lot of depth, because not only do we know a lot about the house, but we know a lot about the contents of the house, like the windows, the doors, and the rooms. And this is how we can create very complex data structures just from very simple classes. Now we can get even more in depth, and this is where something called inheritance comes in. So we have this generic type called room. But what if we want to create a specific type of room, like a kitchen? Well, we can do that. We can create a new class called kitchen. And we can have kitchen build upon what we've already defined in room. So in order to do that, we can do extends room. And this is going to give us an error because we need to create a constructor which matches. Okay, so there's a lot going on here, but basically we have our room and we're creating a kitchen as a subclass of room. So kitchen inherits all of the properties from room, but then has more properties on top of it. So we have room, which has contents, but we could have kitchen, which has its own set of properties as well as contents. So for example, we can have a cooker, and again we could create a cooker object, and that would give us information about a cooker. But a cooker would be specific to a kitchen. Not every room has a kitchen, but we don't want to have to duplicate code by creating the contents in kitchen. And this also lets us store our kitchen as a room. So if I go back to my main, I can have room kitchen equals new kitchen. And again, I'd have to create a new list object in order to do that. So new array list, apologies. And that would be object. Actually, that's redundant. And that creates a kitchen object, but we're storing it as a room. And that's because kitchen extends from room. So that is a very basic introduction to inheritance. Next, we have abstraction, which helps us reduce complexity in our code. So if you think of a specific object like a coffee machine, you put in the coffee beans, you press the button, and coffee starts pouring into your cup. Do you know what's happening inside of the coffee machine? No, because we've abstracted away that information. And that is incredibly useful for us, because we don't need to get into particulars of how it does it. We can just say coffee machine.brew. And for this, we can create our coffee machine object. And we can define its characteristics, or we could have methods. So we could have amount of beans. We could have powered on. And if I could spell Boolean correctly, there we go, got there in the end. And again, we create our constructor. Oh, I forgot to press Control A. There we go. And now we can create some methods which describe coffee machine. So we could have it power on. So, and for this example, we're not actually going to use parameters in our constructor. We'll just set this to false and this to 0, because that's going to be the default for our coffee machine. So we have public void power on. So this will be our method which turns on the coffee machine. So this could be a setter for powered on. So Boolean, powered on equals true. But what if it's already powered on and you try to power it on? Well, that adds an issue. So what we could do is we could say if powered on, throw new exception. That would be an illegal state exception if you want to be specific. And we could say the device is already powered on. Because you can't turn something on if it's already turned on. And this will throw an exception to ensure that the programmer handles this. Now we could do the same for turn off. And we could do the same check if powered off. We throw a new illegal state exception, and I'm just going to copy and paste this. And we'll just change this to off. And then we'll say powered on equals false. If powered on. Sorry about that. Now that we can turn it on and off, we can do some more stuff. Like we could fill the coffee machine. So we could have fill, and we could have amount. And this would be the amount we could fill it by. So in order to do that, we would say amount of beans plus equals, so amount of beans is equal to amount of beans plus amount. And that would add our new amount of beans to amount of beans. But what if the coffee machine is full? Well, we could set a capacity for the machine. In order to do that, we could set a constant. So private static because we only need it to set this once. It doesn't need to be set per coffee machine. It's constant to all coffee machines. and we could have it as an int, and we could say bean capacity. And we can set that to 250 beans. And this can be final because we're never going to change it. Private static final int. If I can get that right, there we go. And now we need to add more error checking. So we could say if amount of beans plus amount is greater than, and we'll add brackets just to make sure it handles those numbers as intended, is greater than the bean capacity, and this should be named in upper snake case. I apologize. Bean capacity, and we'll update that to reflect that. If amount of beans plus amount is greater than the capacity, then we'll throw an illegal state exception saying, hey, there are already too many beans in the machine. Okay, so now we can make sure that the machine never has more than 250 beans. But where am I going with this? Well, if I have a coffee machine, and we can create a new coffee machine, all I have to do is all I have to say is power on. I don't have to worry about what it's doing behind the hood because we've abstracted that code away. We are interacting with this coffee machine at a much higher level. So it's like the difference between writing something in assembly language versus writing something in Java. We've abstracted away all of that difficult memory stuff, and we just get these really nice objects to work with. So we have coffee machine.power on. Now we could actually have another more complex method, like we could have brew. So brew. And this could have any number of checks. So we could check to see if it's powered on. So if powered on. However, in our case, we want to check if it's not powered on. So we use the exclamation mark to negate that. So if it isn't powered on, say, you must turn this on first. So that makes sure we don't try and brew coffee while the machine's off. And what we can do then is we can check to make sure there's actually beans in the coffee machine. So we could say if amount of beans is greater than 0, then we could actually brew. And we could say, we could just print something out. So there's a shortcut which lets you type out and then tab. And you could say, you have just brewed some coffee. And this will brew some coffee. Well, figuratively speaking, of course. So now I can turn my coffee machine on. But if I try and brew some coffee, and I run this, it's going to throw an exception, or not. Right, let's check. Alright, there's a mistake somewhere. Let's find it. If powered on, brew. So obviously, oh right, I know what I did here. So I need to negate this again, just like we did above. And we'll take this outside, and we'll say throw new, and we'll say not enough beans. Because you'll notice our program didn't do anything because it was inside this if statement. Now we can run it again. And because we'll set, now it'll throw an exception saying not enough beans, and then it will tell us where in our program the error occurred. So I can click this and it will show this is where it threw. And there is a typo here. Enough. There we go. So that's basic error checking. So now we could say coffee machine.fill, and we could give it 260 beans. If I run this, it'll give us an error because there are already too many beans in the machine if you try and add 260. But we could add 250. And now it'll say you've just brewed some coffee. But we could brew coffee indefinitely, so we need to decrease the amount of beans after having brewed some coffee. So we could say the cost of brewing coffee is 50 beans. So what we could do is we could write this dot, or we could just say amount of beans minus equals 50, and that will subtract 50 beans from the amount. However, in this case, it's better to create another constant saying private static final int, and then bean cost per cup, and we'll set that to 50, because down the line, if you want to come back to this code, you want to be able to quickly change simple parameters like this, especially when they're common. So we could have bean cost per cup, and now that'll decrease the amount of beans. But now we want to print out some information about our coffee machine. So we can create that by creating a Tostring method. So IntelliJ will automatically create one for us. So it'll create coffee machine, which is the name of the object, and then it'll open up some curly brackets and give us the values of each of the fields. So if I then print that out, so I could write system.out.println and then coffee machine to string. It'll print out all of our meta information about that particular instance of coffee machine. And it'll say, you've just brewed some coffee, but now our amount of beans is 200, and it's on. But once we're done with it, we should turn it off, right? So power off. And then if I update it, it'll now say powered on. Oh, it'll say the device is already powered off, so there's another mistake. Let's have a look. Powered on equals false. That should be negated. If not powered on, because we have the same check here otherwise. So if I run this again, it'll say powered on equals false, because we've now turned off the machine after we've used it. So that's a basic introduction to several of the object-oriented programming concepts. We have inheritance through kitchen, we have polymorphism through house, and we have abstraction through coffee machine. I'm going to leave it there because this video is already 22 minutes long and I have other things to do with my day. But if you have any questions, just let me know. If I was confusing at any point, just let me know. And if you'd like to see more, let me know.